Welcome in everybody to another lesson. Today we are going to talk about applications of percent. Basically we got some word problems, but this shows you how percent works in the real world. Let's take a look at our first problem here. Alright, let's see. An NFL quarterback so we have an NFL quarterback completed 59.3% of his passes during the last season. He attempted 226 passes. How many did he complete? Alright, so let's read that problem here. We have an NFL quarterback completed 59.3% of his passes during the last season. He attempted 226 passes. How many did he complete? So, read this, figure out what you need. You have 59.3%. So let's write out 59.3% of his passes. Of his passes, he attempted 226 passes. So he completed 59.3% of 226, which is times 226. Now we just have a simple problem here. We need to convert that percent into a decimal. 59.3% as a decimal is 0.593 times the 226. So now we just simply gotta plug this into our calculator here, figure out 0.593 times 226. 0.593 times 226. He completed 134 passes. So the answer is he completed 134 passes. You always want to put the units, because how do we know it's not 134 clowns, 134 meters, or something like that? Always put the units they're looking for. He completed 134 passes. So again, figure out what you need. He completed 59.3% of his passes. He attempted 226. So 59.3% of 226, that's that 59.3% times 226. You convert that 59.3% to a decimal times 226, you come up with 134 passes. And it's really not that bad to do these type of problems. I got more. Sometimes word problems can be overwhelming because they're throwing a lot at you, but it's important to be able to decipher what it is you need exactly. Okay, what's the next one here? Let's see. A lab technician has 540 milliliters of a solution of alcohol and water. Eight percent is alcohol. Help if I could spell, wouldn't it? Almost said alcohol. What is alcohol? Alcohol. How many milliliters are alcohol? How many milliliters are water? All right. So a lab technician has 540 milliliters of a solution of alcohol and water. 8% of that solution is alcohol. How many milliliters are alcohol? How many milliliters are water? So he has a total, they have a total of 540 milliliters of that solution of mixture of alcohol and water. 8% is alcohol. So that tells you 8%. We want to figure out how many milliliters are alcohol. So you'll let A equal milliliters of alcohol. That's what I would do. So A, the milliliters of alcohol, is equal to 8% of 540 milliliters. So because 8% of the 540 is alcohol. So now we would just convert that 8% into a decimal, which is 0.08 times 540 milliliters. All right. Now we need to figure that out as a decimal. Figure it out here. 0.08 times 540. That is 43.2 milliliters. So A equals 43.2 milliliters of alcohol. That's how many milliliters of alcohol they have. If you want to figure out the water content, all you got to do is take that 540 milliliters. So let's see. Let W equal milliliters of water. That's what I would do. So let's see. Your water content is going to be equal to the 540 milliliters minus the 43.2 milliliters, because the rest of what's left over is water. So now we can put that into our handy dandy calculator and see what we get. So we're going to do 540 minus 43.2. You get 496.8. So you will have 496.8 milliliters water. Alright, so again, first thing you did, translate this into a math sentence. Use the let statement. Let A equal your milliliters of alcohol. The milliliters of alcohol, that's 8% of the 540 milliliters. We got 43.2 milliliters. To figure out the rest of it, the water content, you just subtract the amount of alcohol from the total of the solution. You got 496.8 milliliters of water. And that's really all there was to it. Alright. I got another problem like it. almost identical to this one, but a little bit different. I know word problems are not as fun sometimes, but these show the real world applications of percents. Because almost everything you work in the real world is percents. So it definitely helps to have a strong foundation in it. Alright. Let's see, here's another one. A lab technician has 680 milliliters of a solution of water and acid. 3% is acid. How many milliliters are acid? How many milliliters are water? Alright, so we got this problem here. A lab technician has 680 milliliters of a solution of water and acid. 3% of that solution is acid. So how many milliliters of it will be acid? How many of it will be water? Well, first thing we're going to do is solve for the acid content, because they give it to you that 3% of it's acid. So we'll let A equal acid in milliliters. So your acid content is equal to 3% of the 680 milliliters of water, which would be equal to 3% as a decimal, 0.03 times 680 milliliters. Alright, so now we need to take our 0.03 times 680. We'll get the answer to how many milliliters of acid there are, which equals 20.4. There are 20.4 milliliters of acid. Alright, so we got our acid content. They want to know the water. Well, 3% of it was acid, so the rest of it is going to be water. So we will let W equal milliliters of water, right? So then your water content is equal to that 680 milliliters for the total, minus the 20.4 milliliters that was the acid. So the rest of that is going to be nothing but water. So now we just stick this into our calculator, the 680 minus 20.4. So 680 minus 20.4, that's 659.6 milliliters of water. So we'd have 659.6 milliliters of water. And that is your water content. So you now have your acid content of 20.4 milliliters, your water content of 659.6 milliliters. And that would be it. Again, large part of word problems is just trying to understand what they're asking for. The word problems we're doing today aren't too bad. There will be some trickier ones in the future, but today shouldn't be too bad. Alright, what's the next problem here? Let's talk about some test results, alright? So, on a test of 80 items, so there were 80 questions, 80 items. Antonio got 76 correct. What percent were correct? What percent were incorrect? All right, so let me read this again here. On a test of 80 items, Antonio got 76 correct. What percent were correct? What percent were incorrect? So, out of the 80, that is going to, let's see, the correct answer, how many correct? Let's see equal, we will let C equal correct. Alright, so C, the correct number, is equal to 76 out of 80. Alright, so he got 76 out of 80 items. 76 out of 80 were correct. So now we just take this, stick into our calculator, figure out his percentage. Well, that happens to be equal to 0.95% as a decimal. 0.95 rather as a decimal. If we were to convert that to a percent, which they want, he would get, let's just do this let's do this down here. So the correct in percentage he got was 95% correct. So he did pretty well on the test, got 95% correct. Now, what percent are incorrect? If he got 76 correct out of 80, that means there were 4 out of 80 he did not get correct. So we will let M, because I'm going to treat it like he missed them, let M equal incorrect. I don't want to say I. There is a reason I will not use I as a variable. It's way in the future in Algebra 2, but I actually has a numerical value. I'm not going to go into it today, but I don't want to use I as a variable. So the number of incorrect, since he got 76 out of 80 correct, that means he got 4 out of the 80 incorrect. Which now we just take our 4 and divide it by 80. So 4 divided by 80, that's 0.00, that's 0.05. So the number that they want in the percent, that means he got 5% incorrect. So, breaking it down, he got 76 out of 80 correct, got 95% there, which means he missed 4 out of 80, so he got a 5% of the items were incorrect. Alright. What about the next problem here? A similar problem. On a test of 40 items, coal got 33 correct. What percent were correct? What percent were incorrect? All right, so on a test of 40 items, there were 40 total questions. Cole got 33 of those 40 correct. So again, we will let C equal what's correct. So the correct answers he got were 33 out of 40. So now we just take our 33 divided by 40, get it as a decimal, and then we can get it as a percent. So 33 divided by 40, that is equal to 0.825, which means as a percent, he got, move it 2 decimal places to the right, you'll get 82.5% correct. Not terrible. That's not terrible. 82.5%. That's not bad for a test grade. Now we need to figure out how many are incorrect. Again, I'm going to let M equal the incorrect. So if he got 33 out of 40 correct, that means he missed 7 out of 40. So for that percentage, we will set M equal to 7 out of 40. This will tell you how much of a percent it was for incorrect. So now we take take the calculator, divide that by 40, 7 divided by 40. Well, that's just going to give you 0.175. So to get that as a percent, move the decimal place 2 to the right, you'll have 17.5% incorrect. So you'll have 17.5% of those are incorrect. And that's really all there is to those types when you have test questions. You either have correct or incorrect. There is no in between, so you only have 2 types. Alright, what's the next one here? Oh, okay, this is also test results, but it's a little bit different. On a test, one got 85% or 119 of the items correct. How many items were on the test? Alright, so on a test, Juan got 85% or 119 of the items correct. How many items were on the test? So it tells you he got 85% of the questions for a total of 119 correct. We want to figure out how many were on the test. Well, the missing number we don't know is the number of questions. So we will let Q equal the number of items or questions, what have you. I think Q is a great variable for this. So he got 85% of the items, 85% times Q, 85% of the items for 119 of them correct. Well, we need to take that 85% now and convert it into a decimal. You'll have 0.85 Q is equal to 119. Now, if you want to figure out how many questions there were, you take both sides. You want to get that Q by itself, you'll divide by 0.85. So divide both sides by 0.85, and then you'll get your result. You'll get Q by itself. Let's go ahead and do the calculator work. I already know it's going to be 140. So there were 140 total items on the test. So yes, there were 140 items on that test. So 85% of the items correct, it tells you, is 119. You got 119 total correct. Divide both sides by 85%. There are a total of 140 items on the test. That's how we came up with that. Got two more examples here. Two more problems. Alright, what's next? Oh, good one. TV usage. Of the 8,760 hours in a year, most TV sets are on for 2,190 hours. What percent is this? Okay, so of the 8,760 hours in a year, most TV sets are on for 2,190 hours. What percent is this? So it's telling you there's a total of 8,760 hours. That would be your denominator. 8,760, that would be your denominator. Most TV sets are on for 2,190 hours. So TVs are on for 2,190 hours out of the 8,760 hours. If it were of, it'd be multiplication, but out of means division. Of is multiplication, out of is division. So that 2,190 is going to be the numerator. So now we'll simply take the numerator and denominator. We'll perform some division here. Let's go ahead and divide 2,190 divided by 8,760. You get 0.25. So 0.25 is the number. We want to make that a percent. To make that a percent, move the decimal places 2 to the right, you'll get 25%. So the TV stays on for 25% of the year, which is quite a bit of electricity. Well, not anymore in this day and age. Most TVs are smart TVs, but still, we could all work to cut back where we can, I do suppose. So that's the answer to this question, is 25% of the time TVs are on. We do have one more problem here. Oh, this is going to be a fun one. Talking about colds from kissing. Especially with Valentine's Day coming up. How appropriate. So, in a medical study, and this is done by the CDC. These may have changed since this book was written, but see, it was determined that if 800 people kiss someone who has a cold, only 56 will actually catch a cold. What percent is this? Okay. So in a medical study, it was determined that if 800 people kiss someone who has a cold, only 56 will actually catch a cold. What percent is that? This was a study done by the CDC a while back ago, so this may have changed since the early 2000s when this book was written. But, so the total out of 800 people, out of means division, where the total is 800, that's your denominator. Only 56 will actually catch a cold. So 56 out of 800, that is 56 is your numerator. We need to figure out what percent that is. So first we will have 56 divided by 800. We got to get that. That'll come out as a decimal first. So 56 divided by 800. Well, that is equal to 0.07. But they want to know a percent. So you just move the decimal place 2 to the right, you'll end up getting 7%. So yeah, 7% of people who kiss someone with a cold will catch a cold. And I know for all you lovebirds out there, it's very tempting to want to kiss someone even when they have a cold, but not a good idea. You don't want to catch it, especially in this day and age of other viruses too. You have more to worry about than catching a cold in this day and age. But that's enough for today. The next lesson, we're going to talk about sales tax, we're going to talk about commission and discounts. So there'll be some very much more useful stuff to apply to percents. I hope everyone has a good day and take care.